How is a cross-sea bridge constructed? Is draining the seawater necessary? Not at all. Before construction begins, engineers assess the geological conditions beneath the seabed. Workers lower a probing device equipped with a sensor-filled conical probe. As it descends, it measures soil resistance, which varies by geological layer. A sudden spike in resistance indicates a hard layer, helping workers determine how deep the concrete delivery pipes need to be placed. How are the delivery pipes driven into the seabed? Workers first use a crane to place the pipe onto the seabed, then attach a vibratory hammer. The hammer's strong vibrations drive the pipe downward. Additional pipes are connected and continue sinking one after another. By the time the third pipe is installed, the first typically reaches the hard layer and can no longer go deeper. To break through the hard layer, workers first use an auger drill to clear soil inside the pipe. Then, they deploy a DTH, down the hole hammer, with rotating and hammering drill bits that crush the rock. Crushed debris is cleared using compressed air, which flows through internal tubes to blow the fragments up a hollow pipe into a container. Next, workers place a large steel reinforcement frame into the pipe and pour in concrete. This is repeated for each pipe, with about 18 needed per pier. The top sections aren't filled with concrete and will be removed later. Then, a large caisson is lowered and connected to the seabed pipes. Seawater leaks in through the gaps, filling the caisson and preventing work inside. To solve this, an extra pipe section is reserved inside the caisson to contain the incoming water and prevent flooding. Workers then install a steel reinforcement frame inside the caisson and build a formwork around it. Once completed, concrete is poured. The caisson is then removed. Construction of the pier continues upward from the base in the same manner, placing reinforcement frames, building formworks, and pouring concrete. As the height increases, they use a jump form system. This jump form has hydraulic mechanisms at the bottom. Once the concrete hardens, workers use levers to detach the form from the concrete, then hydraulically raise the form system for the next section. At the desired height, workers install anchor seats into the reinforcement frame to facilitate the installation of stay cables later. With the pier complete, workers build scaffolding around it to lay the road deck. They install a steel frame and pour concrete into it. The concrete deck includes many holes that will be used later. The deck is constructed symmetrically in both directions. Once it reaches the required width, a bridge-launching crane is installed. This crane has a powerful hoist to lift precast box girders. Connecting and securing the box girders, workers coat the contact surfaces of the girders with epoxy glue and join them. But glue alone isn't strong enough, so they insert bundled steel strands through the holes and pull them tight using hydraulic jacks, securing the girders together. This process continues as more girders are lifted and connected. Once the right side of the crane finishes, it moves to the left side to continue assembly. When both sides are symmetric, the two cranes can work simultaneously in opposite directions. As the bridge extends, stress may cause cracks. To prevent this, holes are pre-drilled into each box girder and filled with bamboo tubes. Workers then bond polyethylene ducts together, hoist them up, and use a device to thread cables into the ducts. With worker assistance, the cables pass through the anchor seat holes, emerge on the other side, and are tensioned and fixed with jacks solving the cracking problem. For each new box girder, another set of stay cables is installed. Construction proceeds outward in both directions. Each pier segment is constructed simultaneously. Workers align both ends of the deck in the middle. The central gap is filled by setting up a formwork and pouring concrete, completing the full bridge deck.